मैं विकास पांडे आज इलेक्ट्रॉनिक डिवाइसेस एंड सर्किट्स में टुडे टॉपिक इज बायसिंग ऑफ ट्रांजिस्टर एम्पलीफायर, बायसिंग स्टेबिलिटी एंड ट्रांजिस्टर एज सच डिस्कशन पॉइंट्स हैं। तो फर्स्ट ऑफ ऑल डिस्कस होगा बायसिंग ऑफ transistor amplifier. There are several types of amplifier biasing transistor amplifier techniques. Then different type of biasing circuits and various biasing methods of BJT. First method is fixed bias. And second method is collector to base bias, and third method is self bias or voltage divider bias. Then first point discussion, fixed bias and base bias. The circuit is VCC is connected, RB and RC it is connected to the collector, RC collector and bias, and third point is connected to the emitter. This is a VB, positive or negative. Then DC analysis for DC X equal to 1/2 pi f of C, where frequency is 0, then 1/0 is infinite, and collector current IC, apply KCL, then VCC minus IBRB VB and VB is equal to 0. IBRB equal to VCC minus VB, and IB equal to VCC minus VB upon RB. Okay. when VCC and RB are selected for a circuit, IB is fixed, hence the circuit is called fixed bias circuit. When VCC and RB are selected for a circuit, IB is fixed, hence the circuit is called fixed bias circuit. Then IC equal to beta of IB, beta, and IB equal to VCC minus VB upon RB. Okay. And second pointage fixed bias advantage and disadvantages. Advantage simple circuit, which uses very few components, and disadvantage thermal stability is not provided by this circuit. Thermal circuit or thermal stability is not provided by this circuit, so the operations point is not maintained. Then IC equal to beta of IB plus ICEO. Second point is collector to base bias. Second point is collector to base bias. Then collector to base bias, the circuit is VCC RC and IC plus IB. This is collector and it is connected to a RB and base. And third point is emitter. Okay. Positive, negative, VB, IB, IC plus IB and this is VC. For DC analysis, if f for DC analysis f equal to 0, then x equal to 1 upon 2 pi fc, where f equal to 0, then 1 upon 0 equal to infinite, and collector current IC, applying KVL to the base emitter circuit. Then equation is VCC minus IB plus IC into RC minus IBRB minus VB is equal to 0. Then VCC minus IB beta plus 1 RC plus of RB minus VB is equal to 0, and VCC minus VB is equal to IB beta plus 1 RC plus of RB, and IB equal to VCC minus VB upon RB plus beta plus 1 multiplication of RC. It is a equation of collector to base bias or biasing with feedback resistance. Okay. It is if there is a change in beta due to pieces variations between transistor, then IC tends to increase. Okay. And third point is voltage divider bias the circuit is VCC RB RC, this is IC, this is IB plus I, and it is connected to base. emitter, IB, VB, this is R1, this is R2, I, and it is emitter, RE, IE and E, collector, VC, okay. Then apply voltage divider theorem, to find VB. We get VB equal to R2 into I upon R1 I plus IB plus R2 I if therefore I is greater than IB. So VB equal to R2 upon R1 plus R2 multiplication of VCC. The voltage across RE is V is equal to IERE is equal to VB minus VB, that is I equal to VB minus VB upon RE. Apply KVL. Then equation is VCC minus ICRC minus VC minus IERE is equal to 0. That is VCE is equal to VCC minus ICRC minus IERE. Okay. ICRE. VCC minus IERE. And apply KVL to the base emitter junction. Then VT equal to IBRB plus VB plus IERE if IE equal to IC plus IB, then IBRB plus VB plus IC plus IB RE, then VB equal to VT minus IB IB RB plus RE minus IC RE. Okay. Next topic is stability factor and transistor as a switch. Stability factor or biasing stability and transistor as a switch. Okay. Then stability factor if a base emitter junction VCC IC plus IB collector is connected to a base RB IB emitter VB and VC, then stability factor is applying KCL to base emitter junction then VCC is equal to ICRC plus IB RC plus RB plus of VB. When IC changes, when IB changes by del of IB and IC changes by del IC, there is no effect on VCC and VB. So the equation becomes zero equal to del of ICRC plus del of IB RC plus RB plus of 0, then del of IB RC plus RB is equal to minus del of IC RC and del of IB upon del of IC is equal to minus RC upon RC plus RB. Equation 1. Substitute equation 1 in S equal to 1 plus beta upon 1 minus beta del of IB upon del of IC is equal to 1 plus beta upon 1 minus beta minus RC upon RC plus RB and 1 plus beta upon 1 plus beta RC upon RC plus RB. The collector based circuit is having stability factor than fixed bias, hence the circuit provided better stability than fixed bias circuit is S dot equal to minus beta upon RB plus 1 plus beta RC and X double dot equal to IC upon beta S upon S 1 plus beta, and work as a switchage according to thermal rule. Then maximum average power which a transistor can dissipate depends upon the transistor construction and may lies the range from a few milliwatts to 200 watts, and power dissipate within the transistor is predominantly the power dissipated at its collector base junction. So silicon transistor it's between 60 to 100 degree centigrade, and the collector base junction temperature may become of two regions due to rise in ambient temperature and due to self-heating. The increasing in collector current increasing the power dissipated at the collector junction. This is term. Further increases the temperature of the junction and hence increases in the collector current. The power it's referred to as self-heating. The excess heating produced at the collector base junction may burn and destroy two transistors. This situation is called thermal of the transistor. Okay, thank you very much.